Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome to the first online class of artificial intelligence. This lecture will fall under the CLO statement given here. Students will understand to implement classical artificial intelligence techniques. The taxonomy level of this class or this lecture is Cognitio 03 and it is targeting PLO 03. The nodes at the bottom, these nodes which are encircled in a green are called static nodes. These nodes are called static nodes because the values of this node cannot be changed. Again, all the nodes which are marked red belong to max, and the nodes which are marked blue belongs to min. Min will try to get minimum value on the board, and max will try to get maximum value on the board. And uh, it means min will compel max to get minimum value on the table and vice versa. Here max is equal to negative infinity. Max will have this value initially because this negative infinity value is the worst case for the max. Now min will have a value equal to positive infinity. Now we have to understand why max has a negative infinity, because max tries to get maximum value on the board, so minus infinity is the worst case for max. Min tries to get the minimum value on the board, so positive infinity is the worst case for the min. Two observations we have to make during this problem. One is that what is the maximum value at the top, value of max at the top, and which nodes or which subtrees we have to prune or cut. So we can alternatively use alpha for max and beta for min, and this search will start from the left node at the bottom. Now we will proceed further. Okay, the values at each node is represented. For example, the alpha at the top node is minus infinity, as because this node belongs to max or alpha. The min or beta here, its value is equal to plus infinity, and here this node belongs to max, and the value of alpha is equal to minus infinity. Now we will see how this search works. This node belongs to max, and the value of max is minus infinity. Now the player max will look down towards this node and will look to the value of this node, and it will compare the value with minus infinity. So minus infinity is less than 4, and player max try to get the maximum number on the board, so it will adopt value 4. So now at this point uh, minus infinity value will be replaced by 4. So the value of max will now become equal to 4, and the node value here will also become equal to 4. Now the value at this node becomes equal to 4 from minus infinity. So at the top of this node is min beta, and the value of beta is equal to positive infinity. As we know that min tries to get the minimum number in at the board. So here min will look at the node down here, and the value at this node is equal to 4. So min min uh, will compare the value uh, with this node, and alpha is greater than, sorry, plus infinity is greater than 4. So it will adopt 4 because 4 is less than uh, plus infinity. Now the value of min here at this node now equal to 4. Uh, Now min will look at this node to minimize its number, and this node belongs to alpha or max. And here alpha is equal to positive infinity because this node is not searched by the max. So max will look down into the node, and here it will get a value of this node. So again here max will compare this value with the value which it already has. It has minus infinity, so plus 6 is greater than minus infinity, so alpha here will adopt the value plus 6. Now consider this situation. uh, we have alpha is equal to 6. Here at this node alpha is equal to 4, and at the top is beta which is equal to 4. Now under consideration is this node where recently we have got alpha is equal to 6. Whenever alpha is greater than beta, like for example in this case 6 is greater than 4, so all the nodes beneath this node will be pruned off or will be cut off, or there is no need to be searched. Let understand this why this node has been pruned off. Let me first erase all these figures. Now this node has been pruned off or cut off, or it needs not to be searched. The value of alpha here is 6. For example, any node which has value less than 6, that node that has been selected, the value has been adopted by alpha. For example, if we have got 5, still the max will consider this node. And for example, if we have minus values, let's suppose less than 6 less than 6 any value, so alpha will still consider this value equal to 6. If for example the value of a node here somewhere is greater than 6, and let's suppose alpha select this node 7 which is greater than 6, still there will be no effect at this point, because beta will return this 4, because beta has a choice of this node where the value of a node is equal to 4. Now at this node, the top node, alpha is equal to infinity, and this node will look towards the this node min, where the value of the node is equal to 4, beta is equal to 4. So uh, alpha will compare its value with this node. So alpha here have minus infinity, and the value at this node is equal to 4. So alpha will adopt 4 because 4 is greater than negative infinity. Now here the value of alpha at top node is equal to 4. Now again this node will look down here to get some value. This node will looks down here to get some value, and this node will look down here at this point to get some value. Uh, this node belongs to max, and here alpha, the value of max is equal to minus infinity. So max will compare this node with minus infinity. So minus infinity is less than 2, so max will adopt this value 2. So the value at this node is equal to 2. Now again max will search for this node, so the value at this node is equal to 1. It will again compare the value of this node with the current value of alpha, which is equal to 2. So alpha will return the value of 2. So here the value of the node becomes 2, and the value of alpha is equal to 2. Now here we have to find the value of beta at this node. So beta here is positive infinity. So beta will now compare its value positive infinity with this node. The value of this node is equal to 2. So 2 is less than positive infinity. So beta will adopt here a value equal to 2. So here again the value of beta is equal to 2. Now all these nodes have to be pruned or cut off, or there is no need to search these nodes. For example, here this node belongs to max, so max will select 9. Again this node belongs to max, and max will select 3. So for example max select here 9 and max select here 3, so there will be no effect on the beta, because for beta there is a choice where this node is equal to 2. So here these two nodes will be prone off. Okay, the prone off nodes are this one and this one. This whole subtree has been prone off. Now again, this node will search for the next node which belongs to beta, and this node will look at its next node, and this node will look at the bottom. Here it will got a static value. Again here alpha will take value equal to 5, and again it will look at this node. So this value will compare with the value equal to 5. No, 5 4 is less than 5, so alpha will return value equal to 5. Now at the top of this max is min, so min has no choice, so min will get this value equal to 5. So here beta is equal to 5. Now these nodes and these nodes have been pruned. Now we are here, so beta will look down into the node. Now again this node which belongs to max, it will looks down, so here it will find value 5, value 7, and it will get here value 7. Now alpha will become equal to 7. So again here alpha is greater than beta, so there is no need to search all other nodes under this node, so this node will be prone off. So we have find out the value of alpha at the top, and also we have find out that which nodes have been pruned off or cut off or don't need to be searched. So here we call this algorithm as an optimal algorithm for many max, because for example in many max algorithm you have to search for all the nodes, while in this algorithm 1 2 3 4 5 6 that much nodes have been prone off. So the research so the search space has been decreased. Now these nodes have been pruned off, so now beta will look look for the value here. At this node, alpha has got 7, beta, and at this node alpha has got 5, so beta will return value 5. Now alpha will look again the nodes which has been updated. So beta here equal to 4, beta at this node is equal to 2, and beta is this node is equal to 5. So the final value of alpha will become equal to 5.